our problem now. We have an airplane flying at 400 kilometers per hour on a heading of 50 degrees. The wind is blowing at 30 kilometers per hour at a bearing of 153 degrees. We want to determine the ground velocity of the airplane and the direction of the flight. All right. So let's just talk a minute about bearings. Bearings are counted from north, which is 0. So north is 0, and we count bearings in a clockwise direction. So as we go clockwise, the degrees increase. For example, east is 90 degrees. South is 180. West is 270. Okay. So let's look at our flight first in terms of a vector. Okay, so the vector has a magnitude of 400 and the bearing is 50 degrees from the north. Now we're going to look at the wind as a vector. Okay, that's 30 kilometers per hour. That's the magnitude, and the direction is 153 from the north. Okay, I'm going to move this to the end of the flight vector. Okay, so we can basically add those two vectors. The resultant is the actual flight. Okay, and you can see it's basically been pushed slightly by the wind. Okay, so we want to find the length, which will be the speed, and then we need to find the angle from the north, which will be the direction. Okay. So what I'd like to do is think of this as just a triangle first. I'll scale it up a little bit. Okay, and let's forget about bearings for the time being. Just think of this as a triangle and with some unknowns that we want to solve for. Okay. I can find A, which is the magnitude of the flight, using the cosine rule if I can find theta. All right. I can find theta because I know the bearings of the blue vector and the red vector. Okay. So if you imagine the blue vector extended here, right, then this angle inside would be 153 minus 50. So 103. And if I know that angle, then theta is just 180 minus 103. Then we're going to look for this angle, small angle here between the flight plan and the actual flight. If we can get that small angle, then we'll just add it to 50 to get the bearing. Okay, so let's look at the working out here. So there's theta. Okay, so using the cosine rule, you plug all those in. Okay, do the calculation. You'll get A, approximately 394.34. So that's the speed. To find phi, I'm calling this small angle here between the flight plan and the actual flight phi. We use the sine rule. Okay, sine rule, like set it up like that. Solving now for phi. Do the inverse sine of that. That works out to approximately 4.251 degrees. Okay. All right, so this is just using cosine rule, sine rule to get these unknown angles and sides. Just to remind you, the angle that we found here is the small angle between the blue and the orange. All right, we go back now to our vectors, and here is what we need, the velocity. The direction then is 50 degrees, which is the bearing of the blue, plus phi, which is the small angle in between, gives a total of 54.251. Okay, I hope that was helpful.